Hello, everyone, and welcome to today's webinar on data science for the enterprise, a joint presentation from Cloudera, Cazena, and Bardess. My name is Hannah Smelty, and I'll be your moderator today. Before I introduce our presenters, I have just a few housekeeping items. We hope to have time for a Q&A after the webinar, so please type your questions in the Q&A window as you think of them. So anytime throughout the presentation, go ahead and type in those questions. This webinar is being recorded and will be sent to all of the registrants shortly afterwards. The recording will also be available on the Cloudera website along with the presentation deck. Also, if you have any further questions or would like more information about what we covered today, please make sure to answer yes to a survey question, and someone will reach out to you. You can do so by selecting the survey icon button at the bottom of the console and or when it pops up at the end of the webinar. So today we're talking more about operationalizing data science for the enterprise and Cloudera's Data Science Workbench. Before we start off, just to get a bit more context on who's on the phone for our first presenter, I'd like to ask a poll question. So I'm going to go ahead and launch that. The question is, what best describes your organization's use of Apache Spark or Hadoop for data analytics and data science? So just trying to get a sense of your experience with these technologies. If you could go ahead and click one of those answers below, that will help our next presenter, Mark Chisholm, Senior Solution Engineer with Cloudera, know where the audience is as he introduces this solution. So we'll hear from Mark for a bit about Cloudera Data Science Workbench, and then we'll pass things over to Daniel Parton with Bardess to talk more about data science in the enterprise and show a demo. And then we'll close things out with a little bit from Cazena. So let's see what the results of our poll show. Drum roll, please. Ooh, so it looks like about half of the people are using some version of Hadoop or Spark. We've got about close to 20% piloting and evaluating, another 20% interested, no plans, using a very liberal rounding up here. So let's go ahead and get started and introduce Mark Chisholm, Senior Solution Engineer with Cloudera. Welcome, Mark, and please take it away.
Hello. Good afternoon. My name is Mark Chisholm, Senior Solutions Engineer at Cloudera. And what I'd like to do today is give you a bit of early background on Cloudera Data Science Workbench so that we can begin to progress through the webinar along the discussion with data science in general and get a very intricate view of that particular topic from one of our other partners and how we would host that. So let's get rolling. From a Cloudera perspective, we've been developing analytic solutions using Hadoop technologies for many years. With that in mind, we've always embraced data science technologies and also machine learning, but we've put those together generally through integration or consultative engagements that are very unique per customer. So within the last 2 years, we've decided to make it a strategic goal of Cloudera to enable data science and machine learning at enterprise scale, and we'll talk a little bit about what that means. What we would like to do is to consider both worlds. The data science community is very intense with respect to the development of models, the production level deployment of models. And some of the very intricate work that goes on in terms of mapping particular data requirements into business solutions for a given corporation. However, when you tend to look at this from a practical, technical level, there are a number of challenges, and many of these need to be balanced in order to be very effective. From an enterprise perspective, inclusive of making that an asset of the company that you can move forward architecturally and strategically. At the data science level, you tend to get into tasks where you're accessing granular data that gets filtered specifically into models and using a multitude of open source tools. Yet, when you do this, there are still technology elements in terms of provisioning resources, accessing specific research data points, and also considerations for going into production. Now, when you look at it from a data management perspective and on the IT infrastructure side, there are a number of particular systems requirements that need adherence to with respect to security, governance, standards, maintenance, low cost, and self-service access. So these particular challenges need to be balanced effectively to manage and grow these particular skills and capabilities. At Cloudera, we like to call this the data journey, where you start specifically from a basic analytic capability, maybe descriptive analytics, and evolve this into more advanced forms in terms of predictive, prescriptive, and to higher levels. And we'll talk about that in a moment. Now, one thing we may want to point out, you may be asking, well, can't we do this a different way? The typical solution that we've really experienced, prior to the introduction of CDSW, is to really automate it in ways that individuals might do if they're kind of left with the choice to pursue different approaches individually. So, for example, a data science may copy the data to the laptop, or maybe use appliances or cloud services as a quick way to deploy resources to perform their work. Now, when you begin to look at this, it introduces a number of problems in terms of, okay, when we move this data, are there security implications? How do we, from a data governance perspective, track the lineage of this data? For example, we have customers that in the financial services space that may do credit scoring. It's vitally important to understand where that data is coming from and at what level of quality that data might be. So there are tools that can be employed at the IT operational level to ensure that this happens. Now, another concern is collaboration in terms of, okay, do we have the most consistent version of this data from a revision control perspective? So that spells a platform that can provide collaboration. And then as we get into this further, we begin to look at advanced concepts around model management and deployment, where we take a model that we're very comfortable with and begin to put that into production and allow that to be a mainstay of a critical function within our enterprise. We would also like to provide a little bit of independence with our data scientists around the silos that they work in, but also bridging them fairly well from an IT perspective into the production environment. All right, so with that intro, the product that we offer is called Cloudera Data Science Workbench, and what we want to do is accelerate machine learning from research to production. So we take it from the genesis, strictly all the way to the very end in terms of deploying that into a production environment and facilitating business results from a corporation's perspective. What it provides for data scientists are the ability to experiment and evolve faster through the deployment of R, Python, and Scala frameworks directly within the environment of Cloudera Data Science Workbench. It provides a sharing facility for research and code from a whole team perspective or collaborative teams to promote working together. And you can also deploy these particular projects, if you will, into production level resources with adherence to enterprise IT standards that we've mentioned earlier. Now, when you look at it from the IT professional perspective, we're bringing in that expertise from the data science communities, helping them apply to IT standards, and creating data as a resource and as a competency within the organization, facilitating all the business processes that we need to make this very functional for the business. The security aspects are well covered because it's tightly integrated with our mainstay product called CDH, which is a Cloudera distribution for Hadoop. And then we also have the ability to run this anywhere. Today we're talking a lot about specifically deployment in the cloud, but this tool is basically deployed on Cloudera products on any particular type of configuration that a customer may desire to run on. Now, I want to spend the next 2 slides talking about a couple of things, what's under the hood here. In terms of creating a modern data science architecture, we decided that containerized environments with scalable on-demand compute were very important. Not to get too much into the details, but it's built with Docker and Kubernetes, which provide isolation and the ability to quickly reproduce environments. In many ways, it provides a level of independence where data scientists can can explore and research in ways in which they're not committed to breaking any particular environment. So there is a bit of isolation. And there is also flexibility in terms of the access to small data, whether you're copying it in locally or accessing it at enterprise level from a Hadoop scale perspective. The Python, R, and Scala runtimes are immediately available. You have the ability to also use GPU resources and run each of these particular types of frameworks fairly seamlessly within the environment. And security is added as a transparent feature. Typically, it's set and go. And what we mean by that is we work with the IT administrative staff to apply the security. You apply the security as a context within the product, and then the developer essentially can get out of the way and just begin to commit to their work without being concerned about Kerberos credentials or other styles of security credentials. And lastly, it's all deployed with Cloudera Manager. And as we mentioned earlier, we have the ability to deploy this on many environments. And in this particular seminar, we're talking about deploying this in the cloud using the Cazena Data Science Sandbox as a service, which is fully managed in the cloud, which would significantly reduce the amount of runway that you would have to quickly deploy an operable solution and begin working on business problems. One last slide. We're noticing significant advancement with respect to deep learning in the industry. And we've added specific features in current releases of CDSW to support deep learning, specifically with GPUs and the specific hardware elements that drive them. So at basically a local CDS level, it's not uncommon for a lot of our data scientists customers to use things like TensorFlow and some of the ones that you see listed here in more of a single node training perspective. We're also evolving this to a more significant level of scale at the cluster level through our relationships with Intel and DL4J. Our intent here is to extend some of the basic framework facilities to deploy deep learning, train and deploy on these GPU resources on cloud or on-prem for those particular types of use cases that require that. All right, at this point, what are
Go ahead, yeah.
Yeah. I'd like to ask a poll question specifically. Does your organization use a centralized platform for data science?
Yeah, thank you, Mark. That was great. That's a really good introduction and really good context for what Daniel will be talking about next. And this question will set us up a little bit more for that, give us a sense maybe of how some of these technologies are deployed within organizations. So please go ahead and make sure that you have your answer in, that you're well represented. And thank you again, Mark, for that introduction to Cloudera and Cloudera Data Science Workbench. Let's go ahead and see the results. Oh, so it looks like about 29% are using a centralized platform, 10% piloting and evaluating. A bunch of people at Seale, well, I'm not up to about 30% in the sort of planning phase or interested, and then about another 30%, no, we're not sure. So it seems like we have some equal thirds here. So without further ado, let us introduce Dr. Daniel Parton. He's a lead data scientist with Bardess. He has actual hands-on experience as both a data scientist and as a manager of data scientists. So really got a great background to share more about some of these sticky issues with operationalizing data science in the enterprise. Welcome, Daniel.
Thanks, Hannah. So my name is Daniel Parton. I'm the lead data scientist at Bardess. I have a PhD in computational biochemistry, and then I worked in marketing for quite a while before joining Bardess. So Mark provided some great context, or a great description of the Cloudera Data Science Workbench, and I'm going to provide a bit more context about kind of how that solves certain problems in the enterprise. But first, a quick introduction to Bardess, in case you've not heard of us. We're a data consultancy focused on designing and implementing data analytics solutions. We cover kind of all aspects of the data lifecycle, with particular expertise in data science, of course, but also data ops, so things like ETL, storage and processing, and then in terms of those data analytics, BI tools, that kind of thing. And then we're also kind of traditionally very strong management consultants as well. So let's think about how CDSW fits into the enterprise, and also about kind of the evolution of data science. So one thing I really want to stress is the importance of big data in terms of why data science is such a sort of important phrase at the moment. Because a lot of the algorithms which are used in machine learning have actually been around for a long time, maybe since the 60s or so. But what's actually made them useful suddenly in recent history is the availability of huge amounts of data, and also the software and hardware to allow you to actually process that data and run machine learning algorithms at scale. And increasingly, we're seeing that those operations occur in the cloud. So what is a data scientist? So this is just to emphasize the range of skills which are required for data science. On the top left, you can see you need some good skills in programming, often specifically within a big data paradigm, so using platforms like Hadoop and Spark. Then, of course, you need math and statistics theory background. And then, of course, it's vital to also have subject matter expertise for the industry domain in which you're working. And elaborating on that a bit more, a data scientist is kind of often seen as traditionally as a sort of hacker type person who has great theory skills and likes to use various different programming packages and likes to just kind of have the laptop and be able to use whatever tools they want to hack away at the data and find insights. And kind of traditionally, that's really how data science has been done in its relatively short existence so far, which is great in terms of innovation, but it can be a challenge from the enterprise point of view in terms of governing how data science is actually done. So the good news is that data has never been more plentiful. There's huge amounts of data, which comes in from traditional relational databases, or maybe it's streaming in, maybe it's coming from IoT sorts of data sources. And then there's been huge advances in the last decade or so in open source libraries for machine learning and for data wrangling and so on. Any data scientists on the call will recognize a lot of the names on that part of the slide. And in terms of operationalizing and doing data science at scale, the good news is that commodity hardware makes kind of scalable compute much more affordable. But of course, there are some challenges as well. So, firstly, data has to get across multiple systems. So that's especially a problem when you're doing machine learning at scale, because there are specialized platforms for working with data at scale, but they may not necessarily be kind of ready for doing machine learning. So that's one way in which Cloudera Data Science Workbench integrated with the Cloudera HDFS and Hive and so on makes a difference there. And of course, teams want to use various different libraries. Everyone has kind of, every data scientist has their own favorite language. Some people like Python. That's my favorite language. Some people like R. And yeah, like I was saying, traditionally a lot of data science was done on a laptop, so that already indicates that you can't be doing machine learning on a very large scale. And it also means that operationalizing data science models can be very challenging because traditionally a company might try to do this the manual way. They might spin up their own cluster in the cloud and have to install the various tools like Spark and the machine learning libraries, and it's just a very time-consuming process. There's a lot of pressure on the IT group who may or may not have experience with setting up data science and machine learning software. So I think we already saw some of these slides in Mark's portion of the presentation, but just to summarize the different needs for data scientists, they need access to granular data. They want to have the flexibility to use the tools that they prefer. They need to be able to have access to large amounts of compute and storage. It's important for their work to be reproducible, and for their work to be operationalized and put in production as well. Whereas on the data management side, it's important for all the data science work being done to be being done in a secure way, in a governed way, in keeping costs down, of course, and so on. So, one of the challenges of a data scientist will typically just kind of do their own thing. They'll just work on their laptop, and this, of course, presents many challenges from a security and governance point of view. So this is where CDSW comes in. So it provides a wide range of features. Firstly, providing all of the libraries that the data scientists typically use. So, it comes with Python and R and Scala and lots of machine learning libraries and data wrangling libraries, which are typically used with those languages. It's also easy to set up with Spark as well, if you want to do machine learning at scale. It has a number of features to allow collaboration between team members. It makes many aspects of operationalizing machine learning models easy. And then from an IT point of view, one of the big advantages is that it kind of brings the data science to the data. So you have your data set up in Cloudera HDFS and Hive and Impala, and then CDSW just sits on top of that, so you automatically have access to those same data sets. So there's really not much extra to do in terms of setting up the infrastructure there. And you can compare that to sort of setting up things a manual way, where you might have your own Hadoop cluster, and then trying to, if you want to integrate machine learning tools with that, you have to do that separately for Python and R and Spark and so on. And that can be a huge amount of manual work to do all of that. And then, of course, the big question is whether that's going to be secure. And CDSW is installed as part of Cloudera, so it comes with all the same security benefits that Cloudera has. And of course, this can be installed on-prem or in the cloud. So before I go into the live demo, there's a quick case study. So this is a project that I worked on for a retail client that aimed to use clustering to understand the most common types of transactions in their data. So they wanted to find which groups of products tended to be purchased together. They were running this on a Cloudera cluster, working on about 2 billion rows of transaction data. So, far more data than you could really work on a laptop effectively. So we had to use some kind of big data machine learning approach using Spark in this case, and this is where CDSW came in. So the results were that, firstly, the clustering was very successful. They described this particular retail client's transactions with a lot of nuance. We found a lot of interesting sort of clusters that the company might not have thought about before, and this helped us to identify major trends. So we were just tracking KPIs for these different clusters and seeing that certain clusters were doing well, certain ones seemed to be doing badly, and the sums of money involved were very large and important for the company. And so ultimately, these clusters are basically going to transform how the company thinks about their business, from the shop floor up to the board level with things like KPI reporting. And of course, this was all implemented using CDSW, which means that the clustering workflow is easily maintainable, reproducible, and scalable. The specific benefits of CDSW in this case were that there was easy access to the big data sets, which they already had set up in Cloudera HDFS. It was easy to use Spark to apply that clustering on the entire data set. The CDSW notebook environment allows the data scientists to do their kind of hacking, as it were, while staying within a secure environment. And then collaboration allowed the team of data scientists at this particular client to work together effectively. So with that, I'm going to dive into the live demo. So firstly, I'm going to share my screen. Hopefully this will work.
And while Daniel is sharing his screen, I'd like to remind you that you can ask questions at any time using that question button at the bottom of your screen. So especially as he goes through this demo, you have a rock star panel of experts behind you. So please send us those questions if you think of them.
Cool. So hopefully you can see my screen now, and what you see here is Cloudera Data Science Workbench. So first I'm just going to open one Python file, and let's have a look at that in the Workbench. So in this panel here, what we see is the code editor. So you can see that it has syntax highlighting and so on. But when we actually run this Python code, the first thing we have to do is start up a session. So you can see there are different engine kernels available. So these are the different compute engines. So this is kind of a core aspect of how it's for different programming languages used for data science, so Python, Scala, and R. In this case, you can also select an engine profile based on how much memory you need, or how many CPUs. In this case, it's just a small demo, so I'm just going to stick with the default small engine profile. So I hit launch session, and that's going to basically start a Docker container, which will be running this compute environment, which will be running Python, and will come with a lot of the libraries required to do data science work. So this is just a very simple example. It's just creating a data set, a random data set, and applying a classification model to that. So without going into too much detail, I can just select this and run through it. So that's, you can see that's all printing to this session view here, and you can see plots kind of output by matplotlib. We see the ROC curve in this case. Also, for any libraries which are not installed, which you need access to, you can actually run those with access to pip or to conda, whatever libraries you prefer to use. So then we also have access to the terminal. So for any kind of terminal applications that you'd like to use, this is available, and this is especially useful for integration with Git. So Git is installed here. So this is how you can kind of keep your data science work integrated with Git in terms of version management and sharing your Git project with your colleagues. So of course, it's also very easy to access data from the Cloudera HDFS and from Cloudera Hive using CDSW, so you kind of automatically have access to these huge data sets. And the other thing to point out is that this is all running within a Cloudera cluster, so it's firstly managed from within Cloudera, but it's also secure within Cloudera as well. Okay, so let's just look very briefly at a different project showing some Spark code. We have some here. So this code is doing association rule learning using the FP growth algorithm, which is a way to kind of understand, for example, which products are commonly purchased together for a retail client. So you can see these are just the configurations for connecting to Spark and also enabling the arrow sort of columnar data transfer feature. Okay, but I'm not going to go through all of the code in detail. So just to show some other features of CDSW. So firstly, there's a job scheduler. So once we've written our machine learning model, and we've been writing that in the CDSW workbook, and we're happy with how it looks in terms of the those charts we're looking at, like the ROC charts. A lot of the time, for a machine learning model, you might want to rerun it at regular intervals. For example, in marketing, if you're designing a model to predict which cookies are most likely to purchase a product of your company, then you might want to select a new set of cookies every day or every week or something. So this makes it very easy to set up a sort of job schedule for this particular job. It's currently being run every 5 minutes just for demo purposes. You can see the job history. You can kind of change with the settings, decide which kernel to use, and so on. You can also add email recipients. So for people who need to get those reports, you can add the emails here very easily and add attachments and so on. So another feature which was just recently released, which is very cool, is the models feature. So this basically handles the operationalization side of things. So once you have a model which you're happy with, how do you set up a web API so that in your other applications you can have access to that model and make predictions on the fly? So with the models feature, it makes this very easy. So this is one example which I currently have deployed. And you can see we have a sort of test here where we can enter some test data, which I have stored here. So this example is based on sending 3 rows of data, so three rows for which we're going to make a prediction. So I just copy that data into here. This is just to test the API, and then we send that back and we get 3 predictions back. So it's a classification model, so 1 means there's a positive result, 0 means negative, 1 means positive here. And then you have kind of full access to monitoring. So for any errors with the API, then you can very easily go here and look at that. So in terms of the actual code for that, let's take a quick look. This is the code. So it's very similar to the code that I had before. Again, this is just a very simple example for demo purposes. Basically, you just have to set this up so there's a function which is taking JSON input, returning JSON output. Once you've done that, you just kind of set up the model, and CDSW takes care of the rest. So it really makes it very, very quick to go from a machine learning model which a data scientist has just built using their favorite libraries to having a fully deployed machine learning model which you can make predictions against over the web and integrate with other applications So this could be custom web apps which your company has built, or it could be integration with BI tools, for example. I think finally, one last feature I want to show are the experiments. So this basically solves the problem, which I commonly run into when I was working on, especially in a larger data science team. It can be a real problem when somebody runs a machine learning model, and then you need to go back 6 months later and figure out what they did, maybe repeat it or change something. And it can be a real pain to go back and figure out exactly which data set they used, because every data scientist will do different types of data prep on their data. They might use different approaches for evaluating the quality of a machine learning model. So what the experiment feature does is it basically allows you to define the inputs and the important outputs from a machine learning model and then track those. So in this case, this is just one example of an experiment which was run. And you can see it's showing these metrics, ROC and accuracy. These are two important machine learning metrics here. It's also tracking this pickle file, which is basically the machine learning model which has been serialized to disk. So you can kind of go back and look at these metrics and compare those for different experiments. It also stores the session. So this shows the code that was run and the output. And then notice we have these track metric functions here. These are the parts of the code which are actually tracking those metrics and causing them to appear in the experiment. So I think those are all the features I wanted to show in CDSW, just to kind of emphasize that this is all running on a Cloudera cluster, so it's entirely secure within the Cloudera environment. CDSW integrates very tightly with Cloudera, allowing you access to all of the kind of big data frameworks like Hadoop and Hive. It makes everything very easy to be governed. You obviously have settings for allowing user permissions and so on, so it makes it easy for the IT and security groups to govern what is going on. And it also allows the data scientists easily to work with Spark as well. So with that, I think I'll hand back to Hannah.
Thank you very much. That was great. And judging from the questions coming in, you want to keep that demo handy for our Q&A. I'd like to hand it over to Levan Chetty, Head of Product for Cazena. Now, he's going to tell you how Cazena fits into this equation. And without further ado, Levan, why don't you take it away? Explain the role of Cazena.
Thanks, Hannah. So it's really easy to see how all of the automation that CDSW brings, significant efficiencies to data science teams, as well as operational rigor. However, as both Mark and Daniel mentioned, this sophisticated analytic layer relies on data, as well as a variety of compute engines and all the resources that you need available to make this all work. Right, and this is the service that Cazena offers to our customers. So we're a fully managed cloud platform for analytics and data science. So what that means is that we package together the cloud, which can be either Azure or AWS, the full Cloudera stack, and all the DevOps required to provide our customers secure and immediate access to production-ready environments. So what I mean by that production-ready, so Cazena's automation creates secure single-tenant environments that can be easily integrated with our customers' existing enterprises using the Cazena Gateway. And then Cazena takes on all the responsibilities to monitor, manage, and maintain the entire stack so that our customers just focus on data analytics rather than infrastructure, keeping the lights on, compliance, security, etc., which allows their analytic and data science teams to be a lot more productive and then stay within all of those security and governance boundaries that that both Mark and Daniel were alluding to. I think I'll hand it back to you, Hannah, so that we can get into the Q&A.
Great. Thank you very much. And you can learn more about Cazena, of course, on our website, on all of our websites, surprisingly. Let's get into our Q&A panel. We have all of the speakers available and a few questions coming in. So the first one, if somebody wants to bring in additional libraries or bring in additional open source code, can they do that themselves, or does IT need to get involved?
Yeah, so I can take that one. That's a great question. So yes, this can be done directly by the data scientists, and CDSW is set up so they can do that in a way which is also safe. So you're not going to, kind of blow up the cluster, or you're not going to affect other people's work. So firstly, you can install publicly available libraries. So if you're using Python, you can. It's very easy for the data scientist to use pip to do that. I can actually share my screen and show this. So let's go back to the workbench. Oh. I think this should be visible now.
Yep.
Let's go back to the session we had open before. So in the terminal here, if you use the exclamation mark, bang, character, then this gives you access to terminal commands such as pip. So you can just do pip install whatever library. And I think it actually comes with Seaborn, but if you want to install Seaborn, you can do that. The other approach for, I guess if the data scientists have their own open source code, which is not hosted on PyPy, for example, they can upload their code manually. So you can just upload module files directly, or alternatively, you can create a new project, and you have an option to create that project from a Git repo. So you can start from an existing Git repo from GitHub or whatever Git infrastructure you're using, and that will just load in all of the data from there.
Great, thank you. And another question here, does the web API support Open API, OAS specifications?
That's a good question. I actually don't know off the top of my head, so we can certainly get back to you on that. I don't know if Mark knows the answer to that.
Yeah, that's certainly one we would like to get back to you on.
Okay, so we have an action to get back to you on that question. And another question, and then we'll answer the rest of these offline. So last question, this is a great one. Is there a reference website that our listeners can go to and learn more about some of the technical specifications and learn more about Cloudera Data Science Workbench?
Mark, do you want to handle that one? You may know better kind of which website would be the best place to send people to.
So Mark might be muted.
Oh, yes, that might help if I go off mute. Actually, if you go to Cloudera.com, there is a reference to Cloudera Data Science Workbench, and that will take you specifically to information about the product. There are other spots within the website that actually also allow you to download the product as well, inclusive of documentation. I'm also answering a question online and providing those links actually within one of the inbox scenarios. So you should be able to see that later.
Great.
Also from a Cazena perspective, there's also a link as well if you go to Cazena.com.
Super. So we'll be sure to share that with everybody in the follow-up notes from the webinar. I'd like to remind you to answer that survey question at the bottom. You can learn more about all of our companies on our website, and we're certainly happy to share more with you and give you a demo as well. See if we can get back. There we are. So without further ado, let me just also introduce our Fast Start Business Value Pilot. So this is a chance for you to try the Data Science Sandbox as a service in the cloud, and because it's running on Azure AWS, we can get you up and running really quickly. And within 4 weeks, you can be using the platform and see an outcome, which is pretty impressive. In this, even in this cloud age, it can be very complex to get started. So this will help you hit the ground running, make a business impact, and show some value really quickly from your data science program. So you can learn more about that by just clicking yes to that survey question or getting in touch with any of those people on the screen there. And thank you so much to all of our presenters today. Thank you for your thoughtful demonstrations, your insight, and your presentations. Of course, you can find these guys on LinkedIn and learn more from them, and we hope to talk with everybody soon. So thank you so much again for joining us today, and have a great rest of your day.